The little subheading there is comparing and simplifying them. Let's do simplifying first. Some of it's kind of logical. Let's talk about simplifying them first. And when they say simplifying, basically when they simplify, unless you're talking about money, pretty much we always leave off ending zeros with decimals. Just because it's a lot easier to understand. Let me give you for example. If you multiply this, let's say our problem is 0.25 times 0.04. Okay, if I multiply that out, 0.25 times 0.04. By the way, the decimals don't have to line up. In this case, they did. 4 times 25 is 100, right? Where's my decimal go? Well, there are 2 decimal places there and 2 decimal places there for a grand total of, Charlie. So what's going to happen? 1, 2, 3, 4. When you write down your answer, just to make life simple for everybody, don't leave these zeros in here. Why? Well, because it muckies the water. If you were saying this number, you would say this would be 110 thousandths, and nobody knows what 110 thousandths is. You want to change this, leave off, this 0 is needed because it takes up a place. These 2 are not. You just want to write 0.01, because that's 100th. It's like a penny, we can do that. But don't, to simplify it means just leave off those ending zeros because they are not needed. That's pretty simple, isn't it? As a general rule. And then the other thing is to compare decimals. Sometimes that gets a little goofy. You have to be careful with decimals when you compare them. For example, let's say you're comparing this. 0.3 compared to 303. If you are comparing these, a good idea probably, in this case, just like you could take zeros off, you could always put zeros on there. You know, you look at this and automatically you go, that's got a lot more digits, so maybe it's bigger. That's not always the case. So you really want to kind of compare it. You know, this has 3 digits after the decimal. If I put 3 digits after the decimal here, it's like 300 compared to 303. What is bigger? 303. In that case, it worked out. But a case when maybe that doesn't work out is this. What's bigger? 0.2 compared to 0.15. You look at that and you go, well, that's a 15 and that's only a 2. The 15 is bigger, but you can't do that with decimals because this has 2 places after the decimal, so this one you need to put another 0 to think about it like that. This is actually 20 and this is actually 15, so this is bigger. Or another way to look at it may be like this. 0.3 compared to 0.29865438. Again, just because this has all these digits here doesn't necessarily mean it's bigger. What you want to do, another way to think about it is this. Look at the decimal point, okay, and then compare every digit 1 for 1 to the right of it. What's the first digit after the decimal here? A 3. The first digit after the decimal there is a 2. You can stop right there because 3/10 is always going to be bigger than 2/10 no matter what comes after it. This has to be smaller than 3/10 because this is a 2 in the tenths. So you can automatically stop and say, well, this is bigger because it's a 3 in the tenths and that's a 2 in the tenths. And it doesn't matter what follows. You can cross all those off because it will never get You can put as many digits after that as you want, it'll never get to 3/10, ever. Ever. Is that exciting? I can tell by the way you're looking, you're very excited about it. Not really.